Hi everyone, my name is Will Valida. I'm a software engineer and cloud architect, and in this video we're going to learn all about data types in Rust. So first thing I'm going to do, I've got this directory here, learn Rust. This is a GitHub repository, so this is where all our code's going to be stored. So as we learned in the last lesson, we can actually create and build programs using cargo. So what I'm going to do is just in my terminal here, write cargo new, and I'm going to call this project data types. That's going to go ahead and create a new application for me for data types. And in the source file, I've got a Rust file. So what I'm going to do, just make sure that's running correctly. So I'll just go cd into that directory for data types, and then run cargo run. That's going to compile and build my application, and it's going to print out hello world because that's all our program does at the moment. Fantastic. So in this video, we're going to explore four things. We're going to explore the core Rust language concepts, including functions, data types, and variables. We're going to dive into the basic Rust types for text, numbers, Boolean values, and compound data. Then we're going to create and compile our Rust program and also discover how we can print output from our program. So first things first, let's take a look at the basic Rust program structure. So functions in Rust, let me just get rid of that, are a block of code that does a specific task. And when we're writing our Rust programs, we separate the code into blocks based on the task that we're trying to achieve, which makes our code easier to understand and maintain. After we define a function for a task, we can then call that function whenever we need to do it. Now, every Rust program must have one function called main. So we've got our main function right here. And this is the code that's always run first in a Rust program. Within our main function, we can call other functions that we might use in our program, or even within other functions as well. So to declare a function in Rust, we use the fn keyword. So what I'm going to do is I'm going to rewrite this. So if I was to rewrite my main function again, fn is the keyword for a function, and then we declare the function name, and then we tell the compiler how many parameters or arguments a function will accept as an input. So here, there's no parameters in my main function, so there's going to be no parameters required to execute this function. The function body will be the code that does the task of the function, and it's defined in our curly brackets here. And it's best practice to kind of format the code so the opening curly bracket for the function appears right after the argument list in the parameters. You may see some languages do something like this. This is very common in C#, but in Rust, this is considered best practice. So it does differ from language to language, but this is how it is in Rust. Cool, so let's talk about macros. Now, macros are essentially predefined functions in Rust, and println is a very good example of this. So if I just go indent with a tab and write println with exclamation mark and write hello world, there essentially what I'm doing is I'm declaring that within my main function that I'm using the println macro, and that's going to print out hello world to the console. So if I go ahead, open up my terminal and write cd, I'm already in data type, so if I go write cargo run again, I should see that this time, hello world, I've got the capitalization there, that's been printed out to the console. And we can actually do a lot with this macro with println, so we can actually use a little bit of substitution. So if I just open up another curly brackets there, and then type in will. Essentially what I'm saying now, let me just control that capitalization. There's lots of crazy stuff going on with my keyboard. Essentially what I'm saying is that this hello, and then these curly braces, we're going to replace that with, or have a value substitution using will. So if I run that again, cargo run, instead of hello world, hello will is printed out. Fantastic. So the macro processes these arguments in order. So if I wanted to add my second name, add that as another argument, pass in my last name as a second value argument, I'll run that again, and it should say hello Wolverleader. Fantastic, you get the idea. So with this print line macro, we've got a function that accepts kind of string characters, and we can do some value substitution with that as well. Right, so now what we want to do is learn how to create and use variables. So in all kind of programming languages, we write computer programs to work with data. And to store data, we can use variables in name references that we can refer to later in our code. Now in Rust, what I'm going to do is just go underneath here. We declare our variables using the keyword let. So if I go let age and set that to my age, 33. There we've declared a variable of age and assigned the value 33, or the integer 33, to our variable, and that's going to be bound to that value. Now we can do it bind variables to or values to variables in a number of ways. So we can either do it explicitly like this, or we can go let birth year. We can either bind it later on in our program like this, birth year 1991. There we go. Again, as fn is a keyword to define a function, let is reserved for our variables. So here we've kind of declared a variable and bound a value to it initially, let age is equal to 33, and then we've also got an unbounded variable birth year and assigned that to a value 1991 later on in our program. So if I want to use these variables, I can just use print line. So I am years old and use age, and then print line, make sure I don't forget the exclamation mark, I was born in, and use birth year for that. So what I'm going to do, let me just clear the terminal, get a bit of real estate going, run the program. Oh, I deleted my semicolon earlier before. Let me try that again. So clear, cargo run. Fantastic. Hello, Wolverleader. I'm 33 years old. I was born in 1991. Cool. Now in Rust, variable bindings are immutable by default. And when variables are immutable, let me just get rid of that. This essentially means when variables are immutable, a value is bound to our variable and we can't change that value later on. So for instance, say if I wanted to change the value of age to 34, let me get my terminal back up again and run that. There we go, we're going to get that error. So cannot assign twice to a mutable variable. So to actually be able to mutate this value, we have to use the mute keyword. So I'm going to change that variable, let age, into a mutable one. So that's a keyword, another keyword in Rust that we can use. So now what I'll do is I'll add another print line statement. So I am years old, and I'll use the variable age. Make sure I don't forget the semicolon. I'll change the value in line 11, and then I'll say I am now 34 years old. So what do we think is going to happen? So the mutable age, or this variable age, sorry, is now mutable, assigned to 33 years old. And then I change the value to 34, and we're going to print out I am now such and such years old. So get the terminal out. I'll clear that. Cargo run. And there we go. So now because I've made this variable mutable, I can now change its value as we go on in our program. So first up, assign the age assign the value of 33 to this variable age. I print out I am 33 years old. And then I change the value of age 34. So I am now 34 years old. So we are able to change the value of that. In Rust, you can also do something called variable shadowing. So essentially you can declare a new variable that uses the name of an existing variable, and this new declaration will create a new binding. And in Rust, we essentially, there's an operation called shadowing because the new variable shadows the previous variable. The old variable will still exist, It still exists, but you can't refer to it within this scope anymore. So if we just use an example, let me get some more real estate here. So this birth year that I am assigning, what I'm going to do, I'll assign I'll bind the value to it straight away, and then let birth year. What I'll do, if I was actually 34, I would be born the previous year. So I'll minus 1 from that. And let's give that a run. And there we go. So I've assigned the birth year, the value of birth year to be 1991. And then I'm using shadowing, variable shadowing here, to minus 1 from that to print out that I was born in 1990. So what this does, we declare this variable named birth year. We don't define it as immutable because each let operation will create a new variable called birth year while shadowing the previous variable binding. Cool, so let's jump into data types. So Rust is a statically typed language. The compiler must know the exact data type for all of your variables in your code for the program to compile and run. Now the compiler can usually infer the data type for a variable based on what value you bind to the variable. You don't always need to explicitly tell the type to your code. But when many types are possible, you must inform the compiler of the specific type using type annotations. So let's use a bit of an example. So underneath my code here, I'm just going to create a new variable. I'll just go nephew age, and I'm going to give this U3T, and he's 14 years old. So if I print that out, my nephew is years old, and just pass through the nephew age. Sorry, if we were to enclose this variable type in quotation marks like this, the compiler is going to interpret that as a text value rather than a number value, which doesn't match the data type that we specified for the variable itself. So if I go ahead and try and run this, we should see a compiler error. There we go. So expected U32, but found a string type. Now Rust comes with 4 different data types, integer numbers, or built-in primitive data types, sorry. So integer numbers, floating point numbers, Booleans, and characters. There's also more complex data types to work with in Rust, such as data series, string and tuple values, etc. So let's have a look at numbers to start with. Now, integers in Rust are identified by the bit size and the signed property. So here we defined a U32, so U would be a signal that it's unsigned, and then 32 is 32-bit. So signed integers can be positive or negative numbers, and an unsigned integer can only be a positive number. Now the I size and the U size depends on the type of computer that your program is going to be running on. So the 64-bit type is used on a 64-bit architecture. The 32-bit type that I've defined here will be used on a 32-bit architecture. Specifically, if you don't specify the type for an integer and the system can't infer the type, it's going to assign it a 32-bit signed integer by default. Now, Rust also has 2 floating point data type values for decimals, so 32 bits and 64 bits. So if I go ahead and just create one, so let float, and I'm going to assign that to float 32 and assign it to 4.0. That's going to be a float running on 32 bits. So the F there declaring that this is a float. Now all all the primitive numbers in Rust support mathematical operations like addition, subtraction, multiplication, and division. So if I just wanted to use the print line macro, 1 plus 2 is equal, put the value there and just go 1 plus 2, make sure that's a curly brace, And I'll just run that. Cool, so 1 plus 2 equals 3. If I change that to multiplication, run that again, and there we go, 1 times 2 equals 2. Fantastic. So we can use mathematical operations just like we would in every other language. Now, Booleans are a type in Rust used to store truth. So a Boolean type will have 2 possible values, either true or false, and they're widely used in conditional expressions. So if a Boolean statement is, or the value of a Boolean is equal to true, then we can do this action, otherwise do a different action. So let's use an example. So let is bigger none. We go 1 or 2, sorry, is greater than 4, and I'm going to print that out. So is 2 bigger than 4 is a bigger number. There we go. The semicolon, why is that not being added? There we go. Cool, so if we run that, so is 2 bigger than 4? That's false because 4 is the bigger number. So if I was to switch that around, we should say, okay, is 2 bigger than, or less than 4 this time? We can say that's true. Fantastic. So Booleans are very straightforward. Now let's move on to text. So Rust supports text values with 2 basic string types and 1 character type. So a character is a single item, while a string is a series of characters. So what I can do is go let my name is equal to Will. So this is going to be the string type, and this is also known as a string slice, which is a view into string data. Now, most of the time we refer to these types by using reference style syntax that precedes with the type and the ampersand. So if I just do that and string, there we go. We'll cover this later, but for now, this you can really think as a pointer to immutable string data. And string literals are all of type string, so all of this ampersand and string. Now, although string literals are convenient to use, it's not suitable for every single situation where we might want to use text. Not every string will be known at compile time. For an example, if you've got users that are interacting with a program during runtime and it sends text via a terminal, Rust has a second string type named string. Now, this type is allocated on the heap, and when you use the string type, the length of the string or the number of characters doesn't need to be known before the code is compiled. Now we'll talk about ownership in Rust and the borrowing system in Rust in a future module, but for now you can think of the string type, data type, as text data that can be changed as your program runs. And then this string type here is really references into immutable views or into the text data that won't change as your programs run. So let's actually code out a better example of this and also use some characters in our program. So let me define a couple of characters. So let first char. I'll actually specify that this is a char and use a single quotation mark. So there we go. Characters can be used defined with single quotation marks, and strings can be used with double quotation marks. So let last char, specify that as a char as well, L. I think you may know where I'm going with this. And what we can do, we can also let the compile interpret a single item or a single character in quotations as the char type. So let second char I, and then we could also do the same with string as well. So let my name Will, and that can be that will be interpreted as a string by the compiler, and it will be interpreted as a pointer to that string. So there we go. We don't need to include that. The compiler can infer this for that. Cool, so let me show you how we can use this. So So what I'm going to do is use some value substitution here. Is the first character, so is the last character, is the second character, I think you know where I'm going with this, of my name. Cool, so I just put first character, last character, second character, and then my name. Cool, so let me clear this. Just make sure everything looks okay, my macro is spelled correctly. And we'll just go cargo run. Cool, so there's my output. W is the first character, L is the last character, I is the second character of my name, Will. Cool, so now let's look at data collections. And there are two types of data collections I want to focus on in this tutorial, tuples and structs. So a tuple is a grouping, of values of different types collected into one compound value. And the individual values in a tuple is also, is known as elements. Now a tuple will have a fixed length which is equal to the number of its elements, and after a tuple is declared, it can't grow or shrink in size, elements can't be added or removed, and the data type of a tuple is defined by the sequence of the data types in the element. So let's go ahead and define a tuple. So let my dog, and I'm just going to declare my tuple with curly brackets, or just brackets, sorry, Toby 15 and false. Cool, so my dog's name is Toby. He was 15 years old when he passed away, and false is alive, so he's not alive anymore. It's a bit of a grim example, but it's the only one I can really think of on the top of my head. Cool, now the elements of a tuple can be accessed by an index position which starts at 0, and this process is referred to as tuple indexing. So to access the element in a tuple, we use the syntax of the tuple name and also the index or the position of the element itself. So, okay, so what I'm going to do is just use the print line macro. And go, my dog's name was, he was, use value, years old, is he alive? Really apologize for the grim example, but what I'm going to do, just get some more real estate going on here. So to access the elements of this tuple, I use my tuple dot 0. So that will access the first element, then the second element, and then finally the third element. Cool. So get the terminal up again. Cargo run. Oh, need to use string literals there, because I'm using a string, not a character. Let me run that again. Cool, so my dog's name is Toby, he was 15 years old, is he alive? False. There we go. So that's how we can use a tuple, very straightforward. Tuples are really useful if you want to combine different types into a single value. Functions can also use tuples to return multiple values because tuples can hold any number of values, which is pretty cool. Now let's turn our attention to structs. So a struct is a type that is composed of other types, and the elements in a struct are called fields. So like tuples, the fields in a struct can have different data types, but one of the benefits of struct type is that you can name each field so it's clear what the value means. So to work with structs in a Rust program, you first define the struct by the name and then specify the data type for each field. And then you create an instance of the struct with another name. So when you declare the instance, you provide specific values for the fields. Now Rust has 3 struct types, or supports 3 struct types: classic structs, tuple structs, and unit structs. So let's start with classic. To define a struct, I'll go at the top of my file here. And we can just use the struct key type. And call this struct student. I'm going to give it some properties. So name, which will be a string type, level, unsigned 8, and then a remote, which will be bool. Cool, so like a function, the body of a classical struct is defined inside these curly brackets, and then each field in this struct is given a name that's unique within the struct. The type of each field is specified after the name of the property. And these fields are separated via a comma. But the difference here is that our struct doesn't end with a semicolon. So then to actually use this, what I'm going to do, just go back down to my main function. So let student1 is going to be equal to a student. And then the name, I'm going to assign it to my name, so string from Wolverleader. Remote, because I'm a remote worker. And then level, we'll say level 5, just give it a random level. And then to kind of access this, I'll use the print line macro. So is a level programmer. Does he work remotely? And then to access that, I can actually go student1 dot, and then the field name itself. So name, student1 dot level, student1 dot remote. There we go. So what I've done here is I've defined this classical struct for a student, and then I've instantiated that in this variable student1. I've assigned some values, so string for my name, remote, Boolean for my remote, and then an integer for my level. And then to access this struct field, I've just used the name of the struct or the name of the variable plus the name of the property in this struct. Cool, so let me give that a run. And there we go. So Wolverleader is a level 5 programmer. Does he work remotely? True. Fantastic. So that's how classical structs work. And we can also use structs as a tuple. So like a tuple, the body of a tuple struct is defined inside parentheses, and these immediately follow the struct name. So let me go back up to the top of my file, and I'll use struct grades. Here, I don't define any property name, so I just define the data type. So char, then F32. I do put a semicolon after the name of a tuple struct. And then to use the tuple struct, what I can do is I'll declare it here. So let grades is equal to grades. I'll just go A, B. How many characters do I have? 1, 2, 3. And then the grade point average, let's just give that 3.5. And then we can access it pretty much the same way as we would for a classical tuple. So GPA is equal. So there we go. But here what we do is that instead of having to refer it to a property, because we don't have properties, we just refer to it as an index like we do in a normal tuple. So grades 0, 1, 2, and then grades dot 3. Oh, it's a comma after each one. Let me get some spaces going there. Fantastic. So let me run that. Let's see what happens. There we go. So there are the values of my tuple struct being printed out. Again, we access those properties using indexing rather than using the name of the field directly. Cool, so that wraps up this video. In this video, we explored some of the core Rust language concepts, such as functions, data types, and variables. We also took a bit of time to dive into the Rust types for text, numbers, Boolean values, and some compound data types as well. We also recapped some of the concepts of creating, compiling, and running a basic Rust program, and how we can actually print output from our program. All this code, I will tidy this up a little bit because it is very squashed. Let me get rid of that, don't need that anymore. I will tidy this up, I'll add some comments, and I'll push this up to my GitHub repository where all the code for all the Rust lessons that I'm gonna do will be stored. It's in this Learn Rust at github.com/willtheleader. And in the next session, we will dive into if-else expressions. So we covered data types in this video, and now we're going to add a little bit more logic to our Rust applications using if-else expressions and how we can actually use data types in those scenarios. Cool, so thanks for listening. If you like this video, give it a like. If you want to learn more Rust or see more Rust videos, don't forget to subscribe. No matter where you are in the world, I hope you're having a great day, and we'll see you all next time.